3DMakerPro sent me an Eagle LiDAR scanner for testing and review. Could be a charger, a thumb drive, but this box is empty. And they have a USB-A to USB-C for charger. It's a 65 watt GAN charger. So the unit that I have doesn't come with the RTK. They have 4 camera. And this is the LiDAR. It's just pull out cap. It's Livebox LiDAR. There's nothing else in here. So I have this laying around. It's a small tripod. So that I can stand it. They have a contact here. There's a quick release here. Okay, it's quite stiff. Wait, it's lighter than my LiDAR Trion S1. Okay, so this is a battery display. So it's fully charged. Charging port and data port. This will be GPS interface. But they didn't send me a GPS unit and it cannot be upgraded. So I can only use it as a SLAM LiDAR. The rubber seals here is coming loose. Okay, here's comparing with my FJD Trion S1 LiDAR scanner. FJD is still a bit heavier, and I also need to carry computer units and 2 batteries pack, so it's much heavier than this one. This one is much lighter. This one will project in a 60-degree angle, and this one is projected in a 270 degrees, so this one it will see behind me. Let me test it for a few days and then I will come back and tell you what I think about this LiDAR scanner. So today I'm going to make a 3D scan of this car parking. I will make one round and I will return to the starting point here. Right, so I move here to adjust the brightness. So this will be my starting point. I click here, adjust the brightness. I choose indoor and it's very dark. So I'm going to increase the brightness to the max. Click save. Okay, and then I will make a new scan. I'm going to name it. Choose continuous mode. And the camera, I try to turn it on. Save. Okay, now the scanner is initialized, so I need to be standing still. And this will be my starting point and the end point. Okay, system check finished. I click on continue. Okay, this will be the view of the LiDAR, first person view. And if I click here, that would be plan view. So I start walking now. Okay, you can see that this is the point where I am. This is the elevator shaft. I've been scanning for 3 minutes. I think the screen is too small. We are scanning for 7 minutes now. I can see a difference between the floor and the wall. The floor is blue color and the wall is in a light green color. Okay, now I'm going to walk back to the starting point. This will be my end point. Because this is a SLAM LiDAR, so I will stand in the same place that I start and point the 3D scanner toward the starting point. I click on stop and click on save. Okay, that's it. Let's check the result in the computer. Okay, back into my office. Now I'm going to export the 3D scan files. The only way that you can export the files now is by using a USB thumb drive, but this time I will use my external SSD drive because it's faster. So there are two ports here, power and data. I'm gonna plug my SSD into a data port. It's a USB-C, and then I'm going to click on the scan that I just made and click on export. I need to tap it several times because the screen is not very responsive, and then you wait until it's finished and turn off the scanner. Okay, I have already copied the files into my computer. It's a folder and the size is about 2.4 gigabyte for the car parking scan. This is a Ray Studio. You can download it from 3DMakerPro website. Today is 6 April 2025. This is the latest version. Next, I will process the point cloud by open the project. I will click on the folder. That folder is parking. Then I click select folder. Okay, then it will come into this page. There's nothing here because we haven't processed the point cloud. Next, I'm going to click on basic data. Then you come into this menu. They have a point cloud resolve. This will apply a SLAM algorithm into your scan, and it will correct the error data. And the second tab is point cloud filtering, and this will filter out the noise. I found that it worked quite well, especially when I 3D scan while the car is running. It will erase the trace of the car and motorcycles. So I will click this, and I will also click the point cloud thinning. So if you click this too, the process will be a little bit longer. On the right, you see the solving. You have a down sample size. Okay, I'm not quite sure what the downsampling size mean. And auto loop, the default value is off. Sometime when I click on, it gives some issue when the resolving the point cloud. So I will leave it as a default value. The whole process of the 3D scanning with the LiDAR is that you need the point cloud for tracing in CAD. You can recreate a walls, floor, ceiling, and columns with the point cloud that you scan with. You are not going to create a mesh from the point cloud that comes from the 3D LiDAR scanner. Even with the $50,000 LiDAR scanner, you won't be able to create a mesh for the whole building. Okay, when each process is done, on the right of the menu, it has a file come up. It's recalculate result.amap. This one is the raw point cloud that has been processed with the SLAM algorithm, and the second one is the recalculate post. This one is the trajectory. The path that you walk while you are scanning, it's just the coordinate of the LiDAR scanner while you are scanning. Okay, now I have come to a sampling process, and it used about 24 gigabyte of RAM. So I have 32 gigs. It's almost hit the limit. Okay, the sampling has finished, and we have our point clouds. I click on EDL. It will give you the edge of the point cloud. What you see here is the ceiling and the floor underneath. There's no other function available for manipulating with the point cloud. I'm going to do this in the CloudCompare, another freeware that you should learn to use when you have Eco LiDAR scanner. And what you should look here is the trajectory. You see here, this is my starting and the end point. Can check the trajectory. When the SLAM algorithm trying to collect the trajectory, start point and the end point should meet. The start and the end point is very close together. This means that the SLAM algorithm is kicking in. Okay, next I'm going to put the color into the point cloud. It's indoor, so I click indoor. I click on start, and then you need to wait for a while. It will use the color from the RGB camera and put that into the point cloud. But as you see in this video, most of the area is dark, so it will come out in a black color, except the area where it's closer to the light. Okay, shading is finished, and I can confirm that you are going to need at least 32 gigs of RAM for processing with the color. There's nothing else that you can do here with the Ray Studio. Okay, if you look here on the right, you see that you can export each file into a different format. You can export in LAS, PCD or PLY, but you actually don't have to. If you look at your project folder, the parking, you will see that there are some new files come in. This file is the original point cloud from the SLAM algorithm. It's 2.3 gigabytes, and this is a filter version. It will filter out the noise. It's 2.1, and this is processed with a subsample. I'm going to use this one because it's the cleanest point cloud result from the 3D scan. And the recalculate pose is the trajectory coordinate. You can just drag these files and drop into CloudCompare, and it will open immediately. And for the shading, you can drag and drop this file, allcolor.pcd. This file is about only 543. You can drag and drop in the CloudCompare, and it will show you the point cloud with the color. Okay, CloudCompare is a freeware. I put the download link in the description. You can drop your color point cloud here, and it will just come up like that. See here, if you click on the top view, it will be like this. So I'm going to rotate it to the XY axis by clicking this icon, and going to rotate on Z axis. Use my mouse to rotate it, right? And then I'm going to move it to the edge of my screen and align one side of the wall. Then I'm going to click check mark. Next I'm going to crop with this tool, the scissors tool. Click on rectangular selection. I'm going to crop just for the building area, and I'm gonna click this one. I'm gonna keep what inside the crop area. I'm going to delete the rest. So now this is the crop version of the color. So what you can do with the point cloud that you just made, you can do a section. See here, this is a section of your point cloud, and you can see that this is the parking lot. I can make it thinner. You can section this, and you can see the parking lot and the floor to floor level. You can see everything here with the color, even the color of the car. Move this down. So I section out the ceiling. You can see the floor. So what is away from the light source is we go into a black color. So when it's this is a fire extinguisher, it's quite obvious. And if you want to keep this section, you click here, slice. Now you can close this, and this section will be safe. All right. For the color, number of point clouds 34 millions. That's quite a lot for the size of this car park. Okay, and if you want to check the dimension of the construction site, let's say column span, you can click on the point cloud and click on here, and then click on one of the point here, and the second point be here, right? So you look for delta x 8.012. Okay, let's move to the next point cloud that we're gonna use. I will use this process. This is a black and white, but it will give you more point. See, it takes longer time to load. This is LAS format, right? It has no color, but if you click on EDL, you see it's give you some shading. This process point cloud is 85 million points. The CloudCompare has the difficulty in loading this 85 million point cloud. So I think this LiDAR scanner is give too many point clouds. It's too much. I'm going to crop this with a rectangular tools. Delete the list. Next, I'm going to align it to the XY plane. I do this by clicking on 3 points. I click on the floor. 1, 2, and 3. Okay, now it's aligned to the XY plane. Yeah, it's upside down, so you're gonna need to flip it back by flip it on the x-axis 180 degrees. Okay, now it's flipped back to normal position. I'm going to rotate it in the z-axis. Okay, click on the check mark. Now it's level, but you see here, you're not going to be able to use this in CAD. It's too many of the point clouds. Right, so what I do next, I'm going to reduce the number of the point cloud, only 25% of this. So I choose this command, subsample point cloud. I like Oct3. Let's try with number 10, 11 or 12. So with the 10, I have only 1 million points. I can try Oct3 11. Okay, Oct3 11, you have 3.3 million points. That's a little bit better. Let's change the color. Let's see, slice it. Okay, that will be enough. The line is sharp and thin. Okay, I think this is good enough for making a reverse. Right, I pick this floor for reversing in CAD. I show you how I reverse this in CAD. I'm going to click here. So this will be the portion of the crop, and then I'm going to move this to the origin point, which is 0, 0, 0. I click on registration, move bounding box center to origin. Okay, next I'm going to export this as the PLY format. Click here, save, and click on the PLY mesh. Okay, this is FreeCAD 1.0. I put the download link in the description. If you click on the modes, they have a UI mode here. They have a draft and sketcher that you can choose to draw a 2D CAD, but I prefer to use the sketcher. With the draft, you can make annotation for the dimension, but in the end, you cannot export the dimension. And I prefer to use the sketcher because it has the constraint function. It will help you to create a 2D sketch quicker. Create a new sketch on the XY plane. Click the top view, and I'm gonna close it for now. I'm gonna rename it. So I create a walls in this sketch. Next, I'm going to import the point cloud. Click on open. Okay, now your point cloud is here. Next, I'm going to change the color to the bright color so that I can see it clear. Point cloud dot is quite big. I'm going to change it to 1 so it's smaller. And next I'm going to create a horizontal line from this point to this point. Our wall is not aligned properly to the horizontal, so I will rotate it. I click on the parking, click on placement, and this is the rotation axis that you can do X, Y, and Z. I'm going to rotate on the Z axis, so there's number 1 there. It means that Z axis is activated. I'm going to rotate it, let's try 0.1. Okay, now you see it move. It's moved just a bit. So if I rotate it 0.2 degrees, it will be this part will be too low. So I think 0.1 will be perfect alignment. I click on apply and OK. So now our point cloud is aligned in the horizontal position. So I'm going to go back to the sketch and delete this one. Next, I'm going to create a wall using a box command. Create a wall from this point to this point. And I press D for dimension because the wall is 0.25 for the large building. It's a regulation, so I know that. I didn't scan the outside of the building, so I won't be able to see the outside of the wall. Now you start to see the precision of the 3D scan. See here, all the point cloud generate from Eagle match the straight line. It's showing the precision of the 3D scan. Okay, next I'm going to create this side of the wall. I'm going to type 12.15, and for the wall thickness I'm going to change it to 0.25. The units that come out from the scanner is meter. Next wall, this wall is a bit thicker, so I'm going to create a new wall. I think it's 0.3 for the width, and for the length I'm gonna just place it here. Right, so now we have our wall. The constraint dimension is everywhere. What I do is that I click on the eyes here to hide it. Okay, it's all done. Next I'm going to draw this wall from here to here. So the wall is quite thick. I choose 32.6 and 0.45 for the thickness of the wall. Move it up just a bit here, right? Can I have a second wall? If you go to model tab, you can turn off and turn on the point clouds. Okay, next I'm going to create this wall. I think it's 0.25, and the length is 7.6. Right, I'm gonna move it. I think this line should be aligned with this line, so I will use the constraint to constrain this to this. I'm going to constrain this line to this point, and for the width here I'm gonna put it 7.8. See here, it's exactly 7.8. The precision of the Eagle is good enough for making a floor plan. Right, next I'm going to make this column here. 0.55, 1.85. Okay, now we have these columns. I'm going to array the column by using this command. Choose the column first, and then I'm gonna use this command to array two columns. And from this point, I need only one column. Okay, from this point, this column is smaller, so this one is supposed to be the same. So I place it here. If you look at the number, it's 16 meter, right? 15.97. Actually, it's 16. And the angle is horizontal, so I put 0 degrees. Click enter. Now, second column is here. So you can see the precision of the LiDAR scanner when you reverse it. You see here, the point cloud match the dimension of the building. 0.5, 1.3. Okay, now you have this column, and I'm going to space this column from this column 7.46. I would say 7.45. Okay, that would be the number from here to here. I think it's 30 centimeter, 0.3. Okay, now the relative dimension from this column and this column is correct. Okay, now we have one more columns here. I'm going to use the array. Copy one copy, just one copy from this to this. It's 8 meter. See here, 8.01. If I move my mouse here, 8 meter will be perfect, and the angle is 0. Okay, now you have your next columns, and this column is probably the same as this one, the last one. So I'm going to use the array. Right, use the array to move this. I click here. It's supposed to be the same. 24 meters. You see the number? 24 meters and 0 degrees. Okay. Now I have I didn't save it. You should save it because it's a new software. It could crash anytime. Alright, next I'm going to create this column 0.5 by 3.5 and move it up a bit here, right? it should be aligned with this column. And I'm going to constrain this line to this point. I'm going to lock this line and I'm going to give a dimension. Hit D for dimension. So this one should be 6 meters. It's the regulation. I know that. We measure 5.97. Let's try 6. Let's look okay. Okay, now we have our second row of the columns. I'm going to array this one using select that first, select the box, move array. We have like 1, 2, 3, 4, and probably one last column here. Let's try 4 column first. Click here. If I pick this point, it's 8 meter. You see that? 8 meter, 0 degrees. Okay, now this column is aligned to the column above it, and the precision of the eagle is good. The point cloud is matched, right? Point cloud is matching. Let me hide this. Okay, I will array one more to this position from here to here. I choose one piece. 8 minus 180. Okay, now we have all the columns here. I'm going to create another walls here. I'm going to lock this column and I'm going to align this at this point, and the width here is 0.2. Okay, here's the final walls. Gonna draw it from here to here. Let me turn off the parking. Okay, I'm going to trim this line, right? I'm going to trim this line, trim, and trim. With the going to trim it, right? So now you have your walls. Trim, remove this line, trim. This is pretty much it for the floor layout, ready to export to AutoCAD. So if you are a surveyor, architect, or interior designer, you can make a floor plan, building section, elevation, quick and easy after making a 3D scan. Okay, next I'm going to export this to AutoCAD. How I do that? Click on the walls, the layer that you just made, and click on Files, Export, and choose DXF format. You can't export with the DWG just yet, so now you need DXF format. I'm going to here, parking, tutorial, to the CAD, go on save. Let's bring you to this menu. Click OK. Here in AutoCAD, I'll try to roll out more of the tutorial for making from a 3D scan with the eagle to making a floor plan or a 3D model of the building. Thanks you guys for watching. I'll see you in the next video.